Hello, my name is Subhashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar. And today's topic is Cisco IPv6 address best practices. So we'll discuss about the IP version 6. What is so special about this IPv6 address, and why is it so different from the IPv4? So let's begin. You have to understand the IPv6 address first. IPv6, it is a 128-bit address, and it is totally different from the 32-bit address that we get from the IPv4. So the address space is larger. Unlike IPv4, which uses a 32-bit address space, IPv6 space allows an enormous number of addresses, and there you also have the subnets also, because there every part is known as the quartet, and there are 8 quartets, each is 16-bit. So you have the 2 to the power 16 number of subnets. So that's a huge one. And IPv6 addresses are represented in hexadecimal notation, not in the binary or decimal. And it is divided into 8 groups or 4 hexadecimal digits separated by colons. So definitely there is no longer the dot as a separator, but there is a colon as a separator between the hex text. Now, what is the difference from IPv4? The main difference is address size, notation, and routing efficiency. You can actually transmit a lot of routing prefixes than the IPv4 here. An IPv4 address is 30-bit long, leading to limited address space, whereas IPv6 addresses are 128-bit long. Additionally, IPv6 remains a need for NAT because, see, there is no private and public address in case of the IPv6. So there is no need for this network address translation. IPv6 header structure, if you see, if you compare with the IPv4 header, the IPv6 header is designed to be simpler than the IPv4 header, and it consists of an 8-byte fixed header that includes the following fields: version, that is 4 bits long; traffic class is related to the QS or the quality of service, that is 8 bits long; flow level; payload length, that is 16 bits; next header 8 bits; and hop limit 8 bits. So by streamlining these header fields, IPv6 facilitates faster processing and routing. So it is simpler than the IPv4 if you consider it according to the header structure. So in the routing protocol phase also we see the support of the IPv6, like the OSPF version 3 configuration. OSPF version 3 is a supported OSPF protocol that supports the IPv6, because OSPF, that is the version, the IPv4 supported OSPF, that is OSPFv2, that supports the IPv4, but OSPFv3 supports the version 6 of IP. Then OSPF version 3 is the IP6 version of the OSPF sounding protocol, and its configuration involves enabling OSPF1 router. So you have to go to the router and you have to give IPv6 OSPF and then the process ID, and then you have to give the area and the area ID also. So to define the OSPF areas and router OSPF process ID, you have to enter the OSPF configuration mode. You can do it, and you can also go to the interface level and you can give this IPv6 OSPF process ID command. You can do it in IPv4 level also. Similarly, you can do it in IPv6. In case of EIGRP for IPv6, you have to first enable the command IPv6 unicast routing, and then configuration involves using the router EIGRP and the AS number to initiate the EIGRP for the specified autonomous system, and followed by the interface and the interface number to enable the EIGRP on individual interfaces. Then the BGP for IPv6, border gateway protocol, or the BGP, offers similarly to BGP for IPv4, but requires the use of IPv6 address families. So that is a feature that you have in BGP. You have either the IPv4 address family there or the IPv6 address family. And the configuration involves using the router BGP, and then you give the AS number like the IPv4, and you have to initiate the BGP session, and then you have to give this special option like address family. Then you have to specify explicitly IPv6 to enable the IPv6 address family. Otherwise, it would accept only the IPv4. Now it is important to define temper relationships and proper route filtering. So this is about the IPv6 and its simplifications and also the protocol support. And now I can give a simple example how to configure, say, the IPv6 on the Cisco router. So these are the two routers that you can see, and this is 1841 router because on PT router or on most of the routers IPv6 is not supported because the IPv6 unicast routing, that command should be supported in the IPv6, otherwise you are not having the IPv6 support. So let's go to the router. Now first you have to give IPv6 unicast routing. So now the IPv6 routing is enabled, otherwise it is disabled. Then you go to the particular interface, this time first time 0 by 0, and if no shut is already up, and now IPv6 address. Now here you have to give the unique local address. So IPv6 has three addresses, mainly the global unicast, that is like the public IP of the IPv4, unique local, that is like the private IP of IPv4, and the link local address that is automatically generated. We do not use the link local because it is non-routable. So IPv6 address and unique local starts with the FC00. Say then anything X like 9ABC, say 3C4D, and then 0001. This is a subnet you are getting, and then the entire host or interface ID is 0, like this one. So this way, if you write like this address, this is very big because you are having too much zeros in it. So is it needed? No. You can shorten this address. I can show you. First of all, you cannot omit these zeros, that is after some digits. You cannot delete that. You can delete the or omit the leading zero, means this. Say in the subnet part, you can only write, say, this one, not 0001. But you cannot omit this FC00, you cannot omit. Or say, for example, here you have 90BC instead of A. Can you omit that zero? No. And now you can write only 0, colon 0, colon 0, colon 0, means you can give a single 0 for each hextet in the host interface ID because it's totally blank. And let's say you are not giving the IPv6 address manually, you are not, say, seeing the MAC address, you are not flipping any bit, and you are not adding the FFFE that we add in the IPv6. So you are not doing that padding manually. So you are resorting to some automatic purpose. So in this case, what you need to do, you do for after the subnet, you have to give the double colon, means the entire host or interface ID is blank. Then you have to give the IPv6 prefix, that's a /64, and you have to specify UI-64. That is the stateless auto configuration method that automatically this interface calculates IPv6 address, that is extensible user interface method. And now you see, let's give show IPv6 interface. So you can see that this IPv6 address is there, this one FC00, and it has inserted FFFE here. So this is the entire IPv6 address we have got, and also the link local address with the FE80 is already generated. Also, I have added one loopback interface IPv6 address earlier that you can also see. It begins with FE80, and this is a link local. This one I haven't added, but this one 2001, like the global unicast IP, I added this as a loopback interface earlier. So you can add the loopback also, and also ordinarily you can go to the, say, interface 0 by 0, and you can give IPv6 OSPF process 1 or any process you want, and the area number, say 0. but it will give you an error because you need to have the OSPF router ID here. In the IPv4, in the OSPFv2, it speaks the, say, the highest IP address of the interface as a router ID if you do not configure like the serial interface ID. But here you have to configure the router ID is mandatory, like the BGP. So you have to configure, say, the OSPF. Say if you give the OSPF router ID is not taking here, but you have to say router, then just give the router ID. I'm not sure if it is taking here, but even if you give OSPF, let me check it out. And OSPF is not taking here also, but the command should take router ID like 1111 it should take, but it's not taking. But I think this is a limitation of some packet tracer like that. But anyway, if you want, then definitely the OSPFv3 should be enabled. So we have to configure it manually here. And in that case, you can do one thing. You can go to router OSPF1 and start there must be at least one up IP interface. So I think this participant is already up. So it is already up, but it is again giving you some error that this interface is not up. Let me check the interface fastness 0x0 status. You can give shutdown and again shutdown. So definitely this interface is up and there is no issue I think for this router OSPF to not get started. Yes, now it started. And sometimes it gives some error, you have to again re-enable it, and then if you give the router ID, and yes, it's taking it here. So I've enabled the router ID now finally and give exit and go to the interface and IPv6 OSPF, then the precise one and area is 0. So now you have this OSPF protocol running in the IPv6 environment. If you see show IP protocols, you definitely see the OSPF1 and the router ID is this. So you are definitely seeing that the OSPF protocol is indeed running on this router. So you have seen that this router has support for the OSPF protocols as well. And you have to enable the router ID here in the OSPF, the router OSPF, that is this air from inside the router OSPF area. You can't enable it outside. So this IPv6 is becoming more and more important nowadays because every ISP backbone nowadays supports IPv6. And previously there was time when we had to resort to tunneling, that is the 6 to 4 or the tornado tunneling. Different tunneling methods were there because the ISP infrastructure was not fully developed for the IPv6 transition, and the routers and switches, many of them were not ready for the IPv6. But now I think most of them, or all of them, I should say, the router and switches are upgraded to the IPv6 environment. The firewalls also are ready for the IPv6. So nowadays tunneling is not so much used. It is used, but it is not used so much like the earlier days. So that is about the IPv6 basics, because IPv6 is a very big thing and it is only, you can say, the ABCD or the basics of the IPv6 that I have told you. But it is a very important chapter for CCNA 200301. Also, it is in the NRC and mainly in the ENCODE level, in the CCNP and CCI level. So you can definitely cannot avoid this IPv6. Never you can do it, because you are getting the IPv6 address more important every day, and ISP is giving you IPv6 address for free also nowadays. If you are connected to the internet, you are getting the IPv6 address, and also it gives you the live IPv6 addresses as you do in the case of IPv4. So definitely you have to study this IPv6 very thoroughly for passing your examination and for also for your job prospect. So I think you have got a good understanding of IPv6 from this webinar, and that's it I have for today for the IPv6 basic. I thank you all for watching and joining this webinar. I'll come with some new topic next time. Till then, keep studying.